Hey everyone, it's Megan. I just wanted to show you guys how to do an alkyne synthesis reaction. And today I'm going to show you how to go from this to an internal alkyne. So let's begin. All right, so the first part of our mechanism is we have this and it's going to be reacting with NH2. So let's get started. All right, so what we have is we want to draw out our NH2, and don't forget that it has a negative charge on it. So what we're going to do is the nitrogen is actually going to attach the hydrogen that is attached to one of the bromines. And remember that it doesn't matter which bromine we pick. So what I want to do is I want to draw out our hydrogen right here. So I'm going to pick that hydrogen for right now. And we are going to have the nitrogen go over here, and it is going to attack the hydrogen. The hydrogen is going to come down like this, and then our leaving group is going to leave. All right, the next step is going to be where we have our double bond right here. So now what's going to happen is that NH2 is going to come back again, but we need to remember to draw out our NH2 as NH3 because it came and it got protonated. So remember to draw out all of the bonds. All right, so now we have our NH3, and remember we also need to draw out our leaving group too because that left as well. Now we can continue with the reaction. So we're going to have NH2 come in once again. All right, and so it's going to come in, and once again, it's going to be attacking this hydrogen right here. So we come along, gets protonated. This part is going to come down, and we're going to have those protons go there. And our leaving group, once again, is going to leave. And so now we're going to have our internal alkyne almost. We're almost there, but we want to make sure that we draw out our NH3. We want to make sure we include our leaving group. And then another important thing to note is we still have NH2. And so how are we going to get rid of this? Well, we need to protonate the NH2, and so we're going to do that by taking water and deprotonating the water. Now, some of you may be saying, wait, what happened? I thought that we would take a hydrogen from here or something like that. That only happens with terminal alkynes. So if we have an internal alkyne, then we need to actually use water and protonate it that way. And so the next step is going to look like this. So now we're going to have our internal alkyne. We're going to have our NH3. And last but not least, we're going to have our hydroxide that's left as well. And that's going to be working with the internal alkyne. Now, like I said, some of you may be wondering, well, what happens when we have a terminal alkyne? Let's assume that it is terminal. So this is how it would change if it was terminal. So let's say we have this. We would have our hydrogen right here, and then we're going to have our NH2 with the negative charge. And so what's going to happen is NH2 is actually going to deprotonate it. And so that way, then we're going to get the alkyne anion. We're also going to get, now we're going to have our NH3, which is good news. And then how are we going to take care of this negative charge? Well, we're going to take care of it the same way that we did up here in this area where we used water. And so we're also going to use water once again. And we're going to take the hydrogen off of there. And that's going to result in our terminal alkyne with the hydroxide. So in both cases, we do end up with hydroxide. We do end up with NH3, which is really good, but it just depends on if it's terminal or if it is an internal alkyne. So there you go.